Okay, so on the last problem, we ended on number 7, and now we're going to start with number 8. When you look at number 8, the difference between 14 and 23 is 9, and the difference between 23 and 32 is 9, and so on. So that makes the common difference of this series 9. Once you know the common difference, you can write the pattern. The pattern comes from that formula that you have to have memorized. And you must use this one because it's a common difference, which is addition or subtraction. It's an arithmetic series. So now my first term is definitely 14. If I'm going to write this to find any term at all, I'm going to use n. My common difference is 9. So if I clean this up, I have 14 plus 9n minus 9. So I get 9n plus 5. Here's the pattern that these numbers are forming. And there's 1, 2, 3, 4 terms. So if I write this in sigma notation like the problem says, I am going from n equals 1 to 4. And this would be the answer. Number 9, I am going from 2 to 4. I have to plug in 2 times 2 minus 6 for the first term. And then I need 2 times 3 minus 6 for the second term. And then I need 2 times 4 minus 6 for the final term. And then when I evaluate this, I have 4 minus 6 is negative 2. 6 minus 6 is 0. 8 minus 6 is positive 2. This adds up to 0. And there's a times by 2 out in front. But no matter what I times it by, this will equal 0. Number 10. This is an arithmetic sequence. I'm telling you that. And so if I'm looking for the common difference, I have to use that formula that you have to have memorized. And I'm going to plug in. My first term is 4. I'm using 15 terms. I'm solving for D. And I know the 15th term is 88. So then I can evaluate and solve for D. 88 is equal to 4 plus 14 times D, minus 4 from both sides. And I have 84 is equal to 14D. Divide both sides by 84. Divide both sides by 14, I mean. And the common difference on this problem is 6. Problem 11. Find 3 arithmetic means. So I need 3, and I'm telling you again, it's arithmetic. And I'm starting with negative 2, and I'm going to 8. So again, the formula from before. A sub n is equal to a sub 1 plus n minus 1 times d. Now, my final number is 8. My first number is negative 2. And I know I have 5 terms because I can see it over there. So that would be 5 minus 1. And I don't know the common difference yet. I have to find the common difference. So this would be 8 is equal to negative 2 plus 4 times d. Add 2 to both sides. And I get 10 is equal to 4d. Divide by 4. And the common difference here is 2.5. So once I know that my common difference is 2.5, negative 2 plus 2.5 gives me 0.5. 0.5 plus 2.5 gives me 3. And then add another 2.5 to that. I have 5.5. Add 2.5 to that, and I'm at 8. So it worked out perfect. Now number 12 is a geometric series. Now in a geometric series, I use the formula that I must memorize. A sub n equals a sub 1 times the common ratio raised up to the n minus 1. My first term is 4. My fourth term, so that means I have r to the 4 minus 1, is 62.5, and that's going to go over here. So now if I clean this up, I have 62.5 is equal to 4 times r to the third. Divide out the 4, and I get 15.625 is equal to r to the third power. So if I want to cancel a third power, I use the cubed root, and that gives me r, and the cubed root of 15.625 is 2.5. So now my first term is 4. 4 times 2.5 is 10. 10 times 2.5 is 25. 25 times 2.5 is 62.5. And then 62 times 2.5 is 156.25. And there would be the first 5 terms of the sequence. 13, final problem on the review sheet, says to find the sum of the first 4 terms. Well, if I'm going to find the sum, then I'm going to use the formula that they give me for the sum, which says the sum of a number is equal to the first number times 1 minus the common ratio raised up to the n, all over 1 minus that common ratio. And if you notice, they gave me 2 things, but they didn't tell me the common ratio. I have to figure that out for myself. So the first thing I'm going to do is go back to the other formula that I have to know for geometric, and that's a sub n is equal to a sub 1 times the common ratio to the r minus 1, n minus 1 power. The fourth term is 64, so I'm going to put 64 here. The first term is 27, and I don't know the common ratio, but I went up to 4 terms, so I'm going to have 4 minus 1 as my power. Clean this up. I have 64 is equal to 27 times r to the third. Divide by 27. And if I look at 64 and 27, I might notice that they're both perfect cubes, so maybe I'll leave it in fractional form. Even if you put it as a decimal, you're still going to get the same answer. If I take the cubed root of this fraction, I am going to get 4/3. So there's my common ratio of 4/3. So once I know that common ratio, I don't have to write out all the numbers. I can just find the sum because that's what they wanted me to do. So the sum of this would be the first term times 1 minus 4/3 to the fourth, all over 1 minus 4/3. And so I would need to make sure I'm very careful with my calculator. The top is going to give me negative 58 and 1/3. The bottom gives me negative 1/3. And when I type that in, my final answer would be 175. So the sum of the series, 175. And there you have it.